Today we're going to talk about metric units and how we convert from one metric unit to another. But first, let's just talk for a moment about units in general. Now, I usually tell my students that there's no such thing as a naked number. What do I mean by that? That means that if you have a numerical value in chemistry, 99.99% of the time, there has to be a unit after it. You can't just say that this room, for instance, is 5 long. 5 what? 5 inches, 5 feet, 5 meters. You have to have a number and a unit after it for that number to make any sense. Now, in science, we use something called the International System of Units, or SI units, as our base units. And there are 7 base units that we use to measure characteristics like length, mass, time, temperature, amount of substance, electric current, and luminous intensity. So those units, meter, kilogram, second, Kelvin, mole, ampere, and candela, these units can be used to derive all of the rest of the units. For instance, volume. Volume using SI base units would be measured in meters cubed. Density, for instance, in SI base units would be measured in kilograms per meter cubed. Now, those aren't in chemistry the units we normally measure those quantities in, but they are the SI base units. So what are the common measurement units in chemistry? Well, the most common things we do in the lab in chemistry, at least at this level, are length, mass, volume, and temperature. Length is measured in meters. The most common is the centimeter or the millimeter, are the ones we use most commonly in the lab. Mass is in grams. Volume is measured in liters, although for the metric system, that's what we would call the base unit in the metric system. But most commonly in the lab, we would use milliliters. That's what our graduated cylinders, etc., are measured in. Temperature is measured in kelvins or degrees Celsius in science. I know in this country we always use Fahrenheit to measure temperature and weather. That's our most familiar unit, but we never use Fahrenheit in chemistry. It's always kelvins or degrees Celsius. And here at the beginning, we're going to be concentrating on degrees Celsius. So when we want to have conversions within the metric system, there are metric prefixes that we need to know. Now, if you look in your notes, we have a whole list of metric prefixes, all the way from yada, which is 10 to the 24th, down to yocto, which is 10 to the minus 24th. And there may be ones that are even bigger or smaller than these, but those are the ones that I could find really quickly. So those are the prefixes and their exponential values. That's what we're going to be most concerned with, are these exponential values over here with the prefixes. Now, I'm not going to ask you to memorize all of these, but I am going to ask you to memorize some of them because they are used so frequently. For the ones in class that I'm going to ask you to memorize, mega is the first one, a capital N. It has a metric prefix, or excuse me, a exponential value of 10 to the 6th. Kilo, small k, has a power of 10 or an exponential value of 10 to the 3rd. Centi is 10 to the negative 2nd. Milli, 10 to the negative 3rd. Micro, 10 to the negative 6th. Nano, 10 to the negative 9th. And pico, 10 to the negative 12th. So those are the ones that I'm going to ask you to memorize for this course. Again, we use them quite often, some more than others, but still these are the main ones we use in chemistry, and I would like you to memorize those. So how do I expect you to be able to convert from one system or from one unit to another? Well, the way that I look at this, I call this the metric seesaw. And the metric seesaw simply says, what I mean by that is that if a unit gets bigger, then the number gets smaller. Now, what does that mean? If I have 1 foot and I'm going to want to find that in inches, then and this is not metric, but we're more familiar with feet and inches. If I have 1 foot, when I go from foot to inch, foot is a bigger unit than inch. So would you agree that when I move from foot to inches, my unit gets smaller? Well, if my unit gets smaller, then my number has to get bigger, the metric seesaw. In order for these two, the foot and inch values, to be equivalent, when the unit gets smaller, the number has to get bigger. And as you know, 1 foot is equal to 12 inches. So I went from 1 to 12, got bigger in the number value, but foot to inch got smaller in the unit value. And we're going to use this concept over and over when I'm talking about moving from one metric unit to another. So let's look at this first one and see how I want this done. We're going from centimeters to kilometers. And the first thing I'm going to ask you to do is to write down the power of 10. So centimeters, if you look back up at your chart, that hopefully you've already written down, centimeters is 10 to the minus second. So 10 to the minus second for the prefix for centi. Kilometers, kilo, the prefix is 10 to the third. So if you look at what's happened to our unit, we've gone from an exponent of -2 to an exponent of 3. If you think about a number line, that means we have gone from -2 to 3. We have increased the unit by 5 places. So our unit has gotten bigger by 5 places. Since our unit has gotten bigger by 5 places, our number value better get smaller by 5 places. So if we know that the decimal value is here, to make my number smaller by 5 places, I need to move it 1, 2, 3, 4, 5. I need to move that decimal 5 places to the left to make that 5 places smaller. So 0.0015. Now keep in mind, was that 0 significant to begin with? It was not. There was no decimal showing ending 0, so it wasn't significant. So I do not want to keep it when I write my next answer. Also remember that when you write decimal values, you must write them with a 0 in front. That's required. So the answer for this is 0.0015. The next one, we're going from gigawatts to kilowatts. And if you look up here, you'll notice that giga is not on this particular list, but it is on your list, your extra list that you have. And you'll see that it's equal to 10 to the ninth right here. So we know that that's 10 to the ninth for our power of 10 for our prefix. Kilo, we just established that kilo was 10 to the third. So what happens to the unit this way? This time we're going from 10 to the ninth to 10 to the third. From 9 to 3, we have gotten smaller for our units by 6 places. From 9 to 3 is getting smaller in our units by 6 places. So if I'm going to get smaller for my unit by 6 places, metric seesaw says I better get bigger by 6 places for my number value. And if I want to make this number value bigger by 6 places, I need to move this decimal to the right to make it bigger and bigger. So 1, 2, 3, 4, 5, 6. I need to replace those with zeros. So I end up with a number value that's bigger than 1. And if it's bigger than 1, we don't want to keep those zeros in front. So 25, 3 zeros after it. 25,000. And if you look at your original value, remember those zeros in front do not count as sig figs. So we only want to keep our 25, our 2 and our 5 for our sig figs. So we do not want to add a decimal or do anything else. Because remember, if we put, don't do this because it's wrong, but if we put a decimal there, then our value would now have 5 sig figs, and we don't want it to have 5 sig figs. We only want 2. So the answer is 25,000. See if you can do the next one yourself real quick. So hopefully you've looked at this one, and hopefully the very first thing you did was to figure out what our metric prefixes were. Milligrams, milli is 10 to the negative third. Micro, 10 to the negative sixth. So we went from an exponent of negative 3 to an exponent of negative 6. From negative 3 to negative 6. Now be careful. People tell me all the time that the unit just got bigger by 3. No, it didn't. Negative 3 to 6, negative 6 on a number line means you just got smaller by 3 places. So smaller by 3 places for our unit. Metric seesaw says then I better get bigger by 3 places for my number. So if the decimal is known to be at the end, since there's no decimal showing, then I need to move that decimal 3 places bigger. I need to make that number bigger. 1, 2, 3, replace it with zeros. Think about it. Do I want to keep that decimal? Do I want to put that decimal in? Hopefully you thought no, because the original 10 with no decimal only had 1 sig fig because there was no decimal showing. So if we put a decimal on that 10,000, we'd end up with 4 extra sig figs because those zeros would turn significant. So we want to keep that at 10,000. Okay, the next one shows us another little bit of a glitch on this next one. If you'll notice, we have nanoliters first of all, and nano up here is 10 to the minus ninth. I'm going to do that in blue to keep my system the same way as I've had it before. 10 to the minus ninth for nano. Now look at liters. There is no prefix for liters. If there's no prefix, then the power of 10, if you look on your chart, the power of 10 for 0 prefixes is 10 to the 0. So now what's happening to us as far as our number line is concerned for our exponent? We're going from negative 9 to 0. And if you think about that on a number line, we're getting bigger by 9 places. So bigger by 9 places for our unit means our number better get smaller by 9 places. So mark where the decimal is understood to be. Since it's not showing, it's understood to be at the end, and we're going to make this number 9 places smaller. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Replace those with zeros. Put our decimal in, because without the decimal here, we wouldn't have the correct number value. So 0.000125. Now, what's wrong with this number, first of all? Hopefully you realize that it needed a 0 at the front. In addition, do I want to have the zeros, those 3 zeros at the end? And hopefully your answer is no, because those first 3 digits in that original number were the only ones that were significant. So those are the only ones that I'm going to keep in that final answer. So that's how we convert back and forth when we're dealing with regular values. Now, I have to admit, I would much rather deal with exponents. It's so much easier to deal with exponents. In fact, I will usually change my regular numbers to exponents first before I try to change them to a different unit. Let's look at how easy it is. When we look at this first one, we're going from milligrams to grams. We've got an M, a milligram, 10 to the minus third, and just a plain gram. No prefixes means, yeah, no, or 10 to the 0 for a power of 10 for an exponential value. So what's happening to our unit? Our unit is going from negative 3 to 0, so it's getting bigger by 3 places. So our number value better get smaller by 3 places. Now here is the beauty part of exponential notation or scientific notation. All I have to do is change this power of 10 and make it smaller by 3 places. I just have to take 4 minus 3, which is going to give me 1. I don't have to worry about having the correct sig figs because it already has the right sig figs. I'm simply going to write 7.30 times 10 to the minus 1 for my answer. Try the next one real quick yourself. Okay, hopefully you paused it and tried it. If you don't pause and try these things when I ask you to, you're not manipulating the data yourself, and it's not going to help you learn it as well. But this capital N stands for mega, and mega, remember, is 10 to the 6th. Over here, just plain hertz, HZ is the abbreviation for hertz, with no prefix, that's going to mean this is 10 to the 0, which means that I have what happening to my units? Getting smaller by 6 places, going from a 6 to a 0. So metric seesaw says, what do I have to do to my number? I have to get bigger by 6 places. And what's all that I have to change? Just the exponent when it's already in scientific notation. So all I have to do is make that 1 6 places bigger. So 1 plus 6, I'm going to end up with 2.0 times 10 to the 7th hertz. Much nicer when you do it in scientific notation. And finally, the last one, watch this one. Many times people see that M and they automatically think milli. But if there's only a single abbreviation there, it's the unit itself. So this is actually just meter. This one has no prefix. 0 prefix means 10 to the 0 for an exponent. Nano is 10 to the minus 9th. So what's happening to our units? We're going from a 0 to a -9. We're getting smaller by 9 places. Metric seesaw says we better make our number bigger by 9 places. So if we've got a -7 on a number line and we're making that bigger by 9 places, we're adding 9 to that -7, we end up with, I almost wrote down the previous value, we end up with 1.35 times 10 to the 2nd. So if you didn't get that, draw out your number line real quick and you'll see that if you start with a -7 and make it 9 places bigger, you'll end up with a 2.